Testing, testing, testing. Hi there, guys. My name is Rohan Bevan. Today we are going to be talking about stress and strain. Today we are going to be talking about, stress and strain. Okay? And what are they? So let's just say we just take a beam made out of metal. Okay? So just some random metal beam. Okay? Now, let's say we apply some force onto it, okay? Here we have this beam, just this random beam, okay? And let's say we just apply some force onto this, okay? We applied a force, and this is the act of something called stress, okay? We'll talk about it a bit later. So we're pressing down on the beam, right? Inside the beam, right? The molecules, the atoms, okay? They feel like they're being pushed a little, right? They're getting a bit too close to each other. So they want to push back, right? So this causes interatomic and intermolecular forces to push back. And if the force, okay, was within within the beam's elastic limits, if the force is removed, then the beam, instead it was pushed all the way here, it would just go back right to where it was before, okay? So this was an example of stress, okay? But what is stress? Well, mathematically, stress equals force force divided by cross-sectional area, or A. So we can put this into F divided by A, okay? F over A. So this is what it is, A being cross-sectional area. So this is what stress is technically is in mathematical terms, okay? So now let's do a little bit of experimenting. Let's say we, instead of F Newton, okay, let's say we add a bit more. F10 Newton, okay? We do that. Now, just with common sense and with actual proof, we know that this would make the force, more forcier. It makes it more powerful, right? So it does more stress, more force. Okay, we can know this because in mathematical terms, it would be F plus 10 over A. And since the numerator is more than the denominator, then that would mean that the force would be stronger. But let's say we do this the opposite way. Let's say we made the area 10 newtons more, okay? I mean, not so that would be A plus 10 meters squared. What would happen? Well, just from the first example, in this, since the denominator is more, that would mean that less stress would be applied since there's more area, okay? So what is the SI unit of stress? It is Newton over meter squared, okay? So this is the SI unit of stress internationally, okay? So that's what stress is, okay? But what is strain, okay? So let's say we take a cube, right? Not a cube, but another beam, okay? Let's say we just take the remnants of that, a new beam, right? We do the same thing. We add some force to it. But what is stress? I mean, not stress, but what is strain? Well, to put it in simple terms, it's basically the comparison between the before effect and the after effect of the stress, okay? So we basically apply some stress on it, right? So what strain is the change in the dimension over the original dimension. So we could put it like this. So here we have our beam, right? We apply force, okay? This is the length of the beam, and this is delta L, okay? So the length of the beam, we L, and this is delta L. So this is the change between it, okay? So if we do it like this, mathematical terms, it would be delta L over L, okay? And this basically compares the the between of it, okay? It compares that fully. And right now we're using strain in terms of length. It can not only be in terms of length, it can be in terms of volume. So let's say we get a ball, okay? So it has a volume, okay? We squeeze that ball, okay? It changes volume, right? Strain is basically the comparison of the regular volume compared to the new volume. Well, like the difference between it, okay? So we apply force to it, right? So since we applied the said force on it, like I said before, right? It changes the volume. So, but do note that the delta V is not the exact volume of the new volume of the ball. Okay, that's completely something else. Delta V is how much that changed during from the regular volume to that other volume. That's what delta V is. And it can also be used in area. For example, let's say we have this square cube, okay? We stretch it out, okay? We stretch it out with two forces. We stretch it out, okay? We can put it as delta A over A, since this is our regular area, and we're comparing the regular area with the new additions of the area, okay? So that would be delta A, the new additioning to it, okay? So that's basically what stress and strain is, and that's basically it. Thank you for watching this video, and hope to see you next time. Bye-bye!